Hi. My name is Federico, and I'm working for Red Hat in the OVirt storage group. And I'm here to present you the current integration between OVirt and OpenStack Storage. So the presentation is mostly about the integration between OVirt and OpenStack, but I will give you a short introduction about OVirt and OpenStack just to get you started on what they are. Then I'll go over the current integration, so what we have today with the OVirt and Glance integration, always in the storage side. Importing and exporting Glance images and current limitations. And then I'll go over what we will have in the future with the Glance, future integration, new things that we can add and improve there. Keystone authentication, and how that is also involved with storage somehow. OVirt and Cinder integration in the coming future. So just to start, what is OVirt? This is the definition that you can find around pretty much everywhere. OVirt is the virtualization management application that manages hardware nodes, storage, and network resources in your data center in order to deploy virtual machines. Right? It's open source, released under the terms of the Apache license, and this is a quite old diagram that you can find, but nothing, like we have some new things going on, but this is pretty much the idea. We have two different web interfaces, the administration portal and the user portal to interact with it, a REST API, then a JBoss application that is the engine that controls the data centers. And then on each node of the cluster, you have VDSM that takes care of controlling those nodes and make them available and usable from the engine to manage basically everything from storages, network, anything that the virtual machine would need to actually run. What is OpenStack? Well, it's a cloud computing project that provides an infrastructure as a service and also controls large pools of compute, storage, and networking resources. Apache license, it's governed by a foundation that was established in September 2012. There might be some overlap in the two projects. They are tailored for different workloads. So today it makes sense to make them living together in the same infrastructure. So that is why we need to integrate them. I won't go much further into the differences, but because the time is really limited. So this is the idea. So the present time, you need some interaction between the two. And as we see, OpenStack can have three different areas of projects: compute, networking, and storage. We will focus on storage, obviously, in the scope of this presentation. And more specifically, we'll look at Glance and how that can benefit in the integration with OVirt, right? So what is Glance? Glance provides services for discovering, registering, and retrieving virtual machine images, right? It has a RESTful API for querying VM images metadata and actually downloading that image. These images can be thought as templates, if you're familiar with that concept in OVirt. Can also be used as backup and has different backends, eventually, like ranging from the simple file system to Swift. It supports several disks formats and containers formats. Disk formats as RAW, QCO, and ISO, and container formats as BER and OVF. You're probably familiar with these if you already used also OVirt. It supports image metadata. Basically, these are some additional information that you can have on the images that are stored in Glance. You can pretty much go over them yourself. I'll just mention 2 of them because they're kind of important in the integration. One is the size. The size has to be intended as the real size of the image of the file that is transferred, uploaded or downloaded from Glance. And the status, there's a special status that is queued, and it is when you have the metadata that is read in Glance, but the image is not there yet. Okay, so these are important for the integration. So we also have some additional properties that are now more standardized in version 2 about the some additional information about the image as the architecture, the hypervisor type, and some other information. We decided not to use these common properties to store oVirt specific information because we wanted to actually have full integration with OpenStack, so that information wouldn't have been consumable by OpenStack. So we are not storing any additional properties in Glance for now. So the interesting use cases for oVirt that can be that we wanted to integrate with are importing and exporting single images or templates from and to Glance, right, for the interoperability with OpenStack. We can be used for backups of images of VMs, and basically also use it as ISO domain. Today, oVirt has something specific that is called ISO domains that are used to store ISO images for the VMs, but we can try to think to leverage Glance also for that. And then the final goal that is really ambitious is to import and export full VMs and templates supporting complete VM definition, multiple disks, and snapshots. So for the initial phase, we just focused on the first point here, which is importing and exporting single images. And basically, that integration has been implemented using something that came along in oVirt 3.3 that are called external providers. So in oVirt 3.3, we introduced the concept of external providers that are services that we are able to understand and integrate with, right? And basically both OpenStack Image, Glance, and Network, and also Foreman has been they have been integrated as external providers in oVirt, right? So we have a new tab in the this is the web admin UI, and this is where you can add new external providers, and this is how it looks like when you have Glance integration here. So the Glance external provider, when you define it, you have several fields that you have to fill in, name, description, the URL of the service, and the authentication, right? You can also test the connection at that point. This pretty much gets you started with it, and as soon as you add this external provider, Glance external provider, you will also find a new storage domain in the storage tab. That is exactly the Glance domain that you just added, and they are somewhat special. They basically are unattached to a storage pool. Up until now, we always had storage domains that were attached to a certain data center, right? In this case, they're not attached to any specific data center, and you can use them, in fact, to import and export images between different data centers. For some operation that we do from the oVirt perspective, we needed to interface with OpenStack services, but OpenStack provides, at the moment, only Python bindings for that, and engine in oVirt is written in Java, so we also started contributing to OpenStack Java SDK as a mean of communication between the engine and the OpenStack services. We tried to stabilize it and add the support for things that we needed. So we can dive in one of the operations that we are actually were interested in the integration, basically, and the glance image discovery, right? So we want to list the images that are provided by the glance service, and basically when you select the glance storage domain in the UI, you will be prompted with you will have a list of images that are available or that you can access on that glance domain. What happens behind the scene is engine that is the oVirt engine that goes to Keystone to request the authentication, gets a token, and then goes to Glance, the Glance provider, external provider that you defined earlier, to get the image list. There's some kind of caching involved here, and then it's displayed in the UI as I showed you before. So once you listed these images that are available in the Glance service, you probably want to import them. So what you do, you can select one of the image, and you can basically click the new button that is import, and what happens is that you will be prompted with a dialog where you can select what data center to use and in which domain you want the image to be imported to and what quota to use for that image. And what happens behind the scene is engine again going to Keystone to request a token. It goes and tries and discovers the image metadata to Glance so that it can create the internal representation of these images inside the engine. And after we have that representation of the image inside the engine, we go and issue the commands to VDSM to create a new volume. So that's the container where we will store the image. And then we will issue a download image that will start the data transfer from Glance to VDSM. So VDSM will go to Glance and download the image data into the volume that we just created. So there's a special case where basically what Glance didn't provide was the image virtual size. So as I said before, basically what Glance gives you is the size of the image. This means that you are not able to discover in advance how large, how big is the image once you attach it to the VM, right? So how large is the disk that the VM will see. This is needed for the internal representation that we keep of the disk inside the engine. So we also need this information. And at the moment, what we do is we go and download the initial part of the image, and we discover the QCO header, and we peek for the virtual size of the disk. So Glance might provide some additional information about the virtual size in the future, but this basically works also for regular HTTP. So this is more compatible just with also other HTTP servers that are serving an image. And we will see later that we can support also that. How this imported image looks in oVirt, it's basically, it can be found in the disks tab, and basically the metadata is maintained, most of it. and then some other information are forged with defaults, like for example the interface that is virt.io, and basically at that point you can create a VM on it or create a template. In 3.4 we automated the process so it can be imported right away as a template, and so at this point we can also look at the other operation that is symmetrical to this, that is exporting disks to Glance. It's pretty much the opposite. So now you go to the disk tab and you select one of the disks and you can export them to a Glance storage domain. You will be prompted again with a dialog where you can select the Glance domain, and that behind the scene will pretty much do the same. The engine will go to Keystone, and well, it will queue the image, as I mentioned before. Basically, we prepare all the metadata about the image in Glance, but the real upload is done by VDSM. In fact, the engine sends an upload image request to VDSM that then streams the data from the volume that we have in our shared storage into Glance. In Glance, this will look like as a regular image. Some of the metadata is maintained, like the name, for example. And basically, this is based on the VDSM support for sharing images that has been added specifically for Glance, but it can be leveraged for other methods of transfer of images. And so we have two new APIs that we use in VDSM that are download image and upload image, and we can issue different methods for the transfer, and one of these is HTTP. That is the one that is used for the for Glance, right? And we can also specify additional headers to it. So, well, as I said, in this way we gain support both for Glance, right, and also for all the other HTTP servers. There's another special case that we have to cover. That is when we download an image that is QCO on a block domain. So this is team provision, means that we create volumes that are, well, on block domains we use LVM, and we create volumes that are not entirely large as the virtual size of the image. We just create them with chunks that then are extended as the VM start using it. In fact, to implement basically team provisioning on block devices. So what happens is that the volume that is created is just probably 1 gigabyte in size. And what happens is that VDSM has to go to the HTTP server or Glance and download and peek for in this case, the actual size of the file that will be transferred. And it will extend the volume to the correct size before downloading it. In all these mechanisms, we have few limitations. We are at the moment limited to not being able to export images with multiple volumes. And this means that we cannot export disks that have snapshot or that are based or team provisioned on a template. And this is because basically we want to export one image that is full contained while we are using external snapshot for volumes, right? And so it means that if we want to export these images, we would have to collapse them. But I have one slide about that later. There is no live VM disk export. Obviously, the VM should be down. But uploading templates is always possible. There's no sparseness support on file domains for raw format. The images are always pre-allocated. means that we are not punching holes in zeros, in series of zeros at the moment, so we download them. Obviously, compression would help in this case. And we cannot resume partial download of the image. So we are moving now to the future. And in fact, these are the ideas for the future improvements of Glance. We can add a few simple operations like deleting images, chain, online squash, that is what I was speaking about, so to support disks that have a snapshot, upload image compression to save bandwidth, and also support sparseness probably. While integrated upload and download via web admin and user portal, so you can upload images or download images from your desktop, and they will be streamed into the volume. As I mentioned earlier, store ISO images in Glance and use them natively in oVirt as ISO domains, basically, and import and export full VMs and templates. So just a few words about the squashing and compression of multiple volumes images that we have in oVirt. So as we see here, we have an image that has 2 snapshots. And basically, the base volume can be either raw or QCO, it doesn't matter, but snapshots 1 and snapshot 2 are 2 QCO volumes. And in order to basically squash the image and see just the latest version, we have to compute the map of the clusters that are scattered around these 3 volumes. And there will be the support for this in QEMU image, right? It will give us a map of blocks that are scattered around in these volumes, and then we will read them sequentially, and after bufferizing them, we can compress them and stream them. So this is just one of the ideas on how to deal with the problem without using some additional space where we basically store the image just for the upload. Other improvements in the area of Keystone are, well, in oVirt 3.4, we introduced a large refactoring of authentication and directory services. Authentication gives you the identity of the user, and the directory service provides a set of information about the user. These have been decoupled, so now you can use them mixing and matching. Basically, you can use the Kerberos authentication with the LDAP directory service if you want to, or any other combination. And Keystone, the Keystone authentication has been sketched as one of these backends, but at the moment we have patches upstream, and if anyone wants to contribute or take them and finish them, is welcome to. So, but this is the current status, and we'll probably have it in the future somehow. The interesting use cases for this integration is that we can consolidate the authentication in Keystone for both data centers, oVirt and OpenStack. We can also associate Keystone users and tenants to oVirt entities and, well, basically give specific permissions and roles to objects that we have in oVirt, like VMs or images or disks. And reuse the same Keystone identities when we are interfacing with these, with the services, with the OpenStack services. So this is probably how it will look like. Authentication goes to Keystone, and you will be granted the access to the web portal in this case for this picture, but to the REST API or anything. And then supposedly later on, you can go to the services reusing those authentication credentials and the token, probably. Another service that in the storage area that we want to integrate with is the Cinder service that provides basically an infrastructure for managing volumes since Fosdem, because previously it was part of the compute node of Nova. Now, since Fosdem has been separated into a specific project itself, that is Cinder, and volumes are persistent read-write block storage devices that most commonly are used through iSCSI, right? Now we have some other that are slightly different. For example, Gluster FS that are attached as a shared, shares, are mounted actually as shares volumes. So, and they have a life cycle that is independent from the VM instances, so you can create VMs that are using these volumes and destroy them and create other new instances that are using it, but they are decoupled, right? Supports a snapshot, and this snapshot can be used for new volumes, and backups are generally archived in Swift. The use cases in oVirt, well, we can think of importing and exporting images from Cinder, but probably the most interesting one is sharing Cinder volumes for the interoperability with OpenStack. And in that way, we will leverage the Cinder volume drivers that they have that for the support of storage appliances for IBM NetApp hardware, Dell, EMC, and in this way gain also the storage offloading capabilities that are coming with the Cinder volumes. And we can also think to unify snapshot and backup strategies in your data center also gain for both oVirt and OpenStack probably. One part of the integration would be to, again, going to Keystone for the authentication and do some simple operation like listing, creating, and deleting volumes in Cinder. And later on, when we actually want to use them, we will, after we created or identify the volumes that we want to use with some oVirt VM, we will either set up the connection or create VM will embed some way of connecting to the to the storage that is provided by Cinder. So this is pretty much what we are planning as future integration with OpenStack. I want to mention that we also have a talk tomorrow about networking, integration between oVirt and OpenStack in networking, so that will complete the picture. And I have useful links for you in mailing list that if you're interested. And there's work in progress of having glance oVirt.org as a repository for images that you could start downloading yourself for your oVirt instance, right? So basically, we will have images of the most important distribution there, and you will be able to, from your installation, to download these templates using Glance. Any question? Sorry. Wait for the mic.
Yeah. Hello.
Hi.
How long do you think the integration with Cinder will take time?
We are planning it for the oVirt 4 release, seems to be. So that's pretty much the time frame, the oVirt 4 release.
There's some function in Cinder, for example, called Cinder Backup. Are you trying to support such things?
We have not specific details exactly of how much of that work. So basically, how much time do we have? Not much. 10? Okay. So basically, the problem in the integration with Cinder is that we have many flows of complex operation that we do on storage that are specific to oVirt. Like, for example, live snapshots or live storage migrations. Right? These are, in the current implementation, are really tailored to how the images are stored in the storage and how they look like in oVirt, right? And all these flows they don't map at all to Cinder. So an easy integration with Cinder would be to leverage what we have already today that are direct LANs. So we already support direct LANs. And we have some operations there that we support, but that's the easiest integration. So you basically can use Cinder volumes as direct LANs, so that's the easiest one. For all the other complex flows, it will require time, definitely.
Thank you.
Okay.
4.0, the release 4.0, is it related to Red Hat Linux 7, or does the schedules match, or is it not allowed to speak public about that?
For EL7 support, we're planning to add it in oVirt 3.5 actually. So as using an EL7 host, RHEL 7 or CentOS 7, as a host is planned for oVirt 3.5. For the engine itself to run, probably will take a bit more time. The interesting part is probably using it as a host.
But can we expect that it's in the Red Hat way like it used to be, where you do a lot of backporting, like with the kernel or stuff like that, that you get some features from the 4.0 release backported to the actual Red Hat package of oVirt?
Usually it's not an issue so much for oVirt or Rev, which is the Red Hat version of it, because we usually rebase each minor version, so we don't have to do a lot of backports for features. Most of the backports are for stabilization, and we're doing a lot of them in upstream oVirt as well. So we just have oVirt 3.3.3 stabilization release for the current oVirt release. So a lot of backports are done both upstream and downstream.
About 7.1, RHEL 7.1, what oVirt version do you expect?
That's too far to say. I don't know the schedule.
I joined a bit late, but I missed the thing about the LDAP integration and all those things. But I've got a lot of customers which are still, please don't beat me up, but which are still running yellow pages through a NIS, which are on a plain Unix user backend without any LDAP integration. I did some POSIX echoes on that to extend the possibilities of groupings and stuff like that. Is there any integration planned for just simple Unix user backends, which are a bit extended regarding POSIX echoes?
You can use, as Federico mentioned, there's a lot of work on refactoring the authentication backend. You can write a plugin for anything now, basically. So
now it's done, right? Oh, we can just mute it.